Good morning. My name is Felicia Orth. I'm a hearing officer appointed by the Environmental Improvement Board to conduct a hearing in a rulemaking docketed by the administrator as EIB 2127. It regards a proposed rule related to ozone precursors, air pollutants. Thank you for joining us this morning. We begin this morning with public comment, and I will tell you who I have on the list.
I was going to, but I wasn't sure if that was.
Hold on, Lou. Please mute yourself. There we go. Let's see. Too many screens open, trying to keep track of the attendees and the chat. All right. So let me tell you the names of the folks that we have who've indicated a desire this morning to offer public comment. The names are, and I will call on you in this order, Curtis Smith, Sister Marlene Parrott, and Sonia SOTO. It is not required that you send us an email before I invite your comment. It's just that I call on the folks who did send us an email before I open it up more generally. Please remember that public comment is limited to 5 minutes. And if there is more to say, I will invite you to put your comment into writing and send it to Pam Jones. All comment, like all testimony in this hearing, is taken under oath and subject to questioning. So let's start. Let me see if Mr. Smith is on the platform. Curtis Smith. It does take me a moment to scroll through the names, so pardon me while I do that. Claudia Colette. I'm sorry, we move right from the C's to the D's. I don't see Mr. Smith. So I know that Sister Parrott is on the platform. I saw her name. Let me get to you. There you are. Sister Parrott, can you hear me?
Yes.
Terrific. If you would please raise your right hand. Do you swear or affirm that you will tell the truth?
I do.
Thank you very much. I will start your 5 minutes now.
Dear members of the Environmental Improvement Board, I am Marlene Parrott, a Sister of Mercy and member of New Mexico Interfaith Power and Light. I am speaking today to encourage the EIB to vote to support and strengthen the New Mexico Environment Department's draft rule to address ozone precursor pollutants from oil and gas operations. These are ethical issues that demands protection of the common good. Oil and gas operations also release hazardous air pollutants such as benzene that is proven to cause cancer, putting those living closest to oil and gas operations at the greatest risk. More than 130,000 New Mexicans live within a half mile of oil and gas development. Rural communities, tribal communities, children, and the elderly are especially at risk. New Mexico is home to some of the worst methane pollution in the county. New Mexico is home to 2 energy-producing regions that are among the nation's most polluted: Eddy, Lea, San Juan, Rio Arriba, and Chavez counties. The 5 New Mexico counties, home to 97% of the state's oil and gas wells, are all at risk of violating federal ozone standards of 70 parts per billion. More methane pollution means accelerated climate change. and an uncertain future for New Mexico's children. Methane is a potent greenhouse gas, 84 times more powerful than carbon dioxide in the near term. In fact, methane pollution contributes to about 25% of the global warming we are experiencing today. This rule is critical for protecting both our health and climate by reducing smog-forming volatile organic compounds, as well as methane, a powerful greenhouse gas responsible for 25% of climate change we are experiencing today. While the Environment Department has put forward a strong proposal, more work needs to be done to protect communities and address major pollution sources to meet Governor Lujan Grisham's goal of nation-leading rules to cut pollution. I would also emphasize that adequate funding for inspection, monitoring, and implementation of violations, corrections, and fines be somewhat addressed. Please adopt a strong final rule that protects communities and addresses major sources of air and climate pollution. Thank you very much.
Thank you very much. All right. Sonia Soto was the next person who indicated a desire to offer public comment this morning. Ms. Soto, let's see if you're on the platform. In the event you are on the platform and you'd like to make a comment, please send a message through the chat. And if you are struggling with the chat function at all, call or send a text to 505-660-4305 and we'll get you taken care of. Ms. Soto, I'm unmuting you. Ms. Soto, can you hear me? Ms. Soto? Oh, there you are. I've unmuted you. Can you hear me?
Can you hear me?
Oh, you're very soft. Can you speak up, please?
Can you hear me now?
Yes, that's much better. Thank you.
Okay. Okay.
Would you, your first name is spelled Sonia, and your last name is Soto.
Yes, ma'am.
All right. Would you raise your right hand, please? Do you swear or affirm to tell the truth?
Yes.
Thank you. Your 5 minutes starts now.
Dear members of the Environmental Improvement Board, I am a member of the CFF and a resident of Eddy County. I live in Carlsbad. I am concerned about the methane pollution because of the effects it has caused in this area. I support methane rules and thank the Environmental Improvement Board for this hearing. My grandson lives here in Carlsbad. Well, we all do. And just seeing in the last 10 years how much Carlsbad has changed, it's very worrisome. I worry about what kind of future he would have if we continue to live here. We are like in a highly polluted area, county, and let me see, our children need us to speak up for them, and we need to make some changes for this area. We're already experiencing impacts of climate change. Our health, the air, the land, our water. Like we used to have a really nice river, and it's just not the same anymore. And I don't think we can ignore it anymore. I think we need to make these changes now. Thank you.
Thank you very much, Ms. Soto. I don't have anyone else indicating in the chat that they wish to offer comment. I don't see any other unidentified call-in users. Pam, did anyone else reach out to you to make comment during this 9 o'clock session? She may have stepped away. Let me just, um, Vice Chair Trujillo Davis, absolutely.
I just want to say thank you to the two members of the public who spoke out this morning. I understand it takes a lot of courage to get on a platform like this and even to stand up in front of the group when we all are gathered. So thank you for taking the time to speak up.
Yes, thank you. Please know that there are 27 more opportunities to offer non-technical public comment. It's at 9 a.m., 1 p.m., and 5 p.m. every day. There will be a general invitation if you're here on the platform, and but best really is to send an email to Pam Jones and identify the slot that you are interested in. So I have a chat message from Sister Brown asking if there's a Kyle on the call. And there we go. Kaylee, Ken, Kim, Kirsten. I'm sorry, there's no Kyle on the call, but please let Kyle know that he can reach
Miss
out to us. Sorry?
Miss Orth, you're cutting in and out. It's Teresa. You're cutting in and out.
Oh, really? Okay.
Yes.
I'm not getting any warning messages, but I will. Does it help if I increase my volume? All right.
We'll see.
Okay. All right. So now I just got a chat message from a staff person saying that I'm not the one cutting out, Teresa. Okay. By the way, if it continues for you, Teresa, although I do watch you carefully to make sure that you're not waving your hands at me, it often helps to turn off your camera if you can.
Madam Hearing Officer, this is Laura Katz. You're also cutting out for me as well, so I don't know if I think it might not just be the court reporter.
Okay, well, thank you for that. I'm getting mixed messages. All right, so let's turn from the technical comment session back to the technical case. And when we ended last night, we were in agreement that we would begin this morning with modeling. So, Ms. Katz? Where are you?
Madam.
Madam Hearing Officer, Mr. Knight is going to be presenting Mr. Morris for the modeling.
Terrific, thank you. You might have said that, and I didn't remember, so thank you. Mr. Knight, whenever you're ready. Do I need to turn Mr. Morris into a panelist, or do we already have him?
Yes, please. If he's not already,
Let's see here. Remind me the first name.
Ralph.
Ralph. Thank you. There he is. Okay.
Can we have the exhibit numbers for this witness?
Yes, Member Trujillo Davis and Madam Hearing Officer, Madam Chair, members of the board. We will be discussing exhibit NMED 107 for the direct testimony and NMED rebuttal exhibit 11 for the rebuttal testimony. And Madam Hearing Officer, the department would like to call Ralph Davis.
Okay, thank you.
Or excuse me, Ralph Morris.
Morris, all right.
Sorry.
Mr. Morris, can you turn on? There you are.
Sure, ma'am.
I see you on the video and you're unmuted. Do keep your voice up, please. And apparently we were speaking at higher speeds yesterday, so toward the end of the day. So if you would, please take care to speak slowly. The transcript in this matter is the official record. If you would raise your right hand, please. Do you swear or affirm to tell the truth?
I do.
Thank you very much. And it looks like Ralph and Morris are both the standard spelling, so thank you.
Good morning, Mr. Morris. Could you tell us where you are employed?
I work for Rambo US Consulting, Inc.
And how long have you worked for Rambo?
Almost 27 years.
And what is your current job title?
I'm a managing principal.
And what are your job duties?
I have two main duties. One is I manage the Central West Business Unit of Rambo Environment and Health that consists of about 130 people in offices in Northern California, Utah, and Colorado. And then I also lead air quality consulting projects, many that have to do with photochemical grid modeling and evaluating the effects that emission controls have on ozone, particulate matter, visibility, and deposition.
Please describe your educational and professional qualifications.
So I have a bachelor's and a master's in mathematics from the University of California. I started my air quality consulting career back in 1979, modeling ozone formation in the Los Angeles basin. And since then, I've developed numerous ozone and particulate matter models and applied them in many different strategies and studies. I was responsible for delivering the urban airshed model that was the first photochemical grid model to EPA, and that was used in the first set of ozone SIPs back in 1994. Since then, I've developed other models that I've used in the ozone transport assessment group. And when I joined Rambo, then Environ back in 1994, I led or co-led the development of the comprehensive air quality model with extension, which is a photochemical grid model that was used in this particular study.
What are some of your more recent photochemical air quality modeling projects?
2 years, I led the photochemical modeling for the Western States Regional Haze SIPs. So that was for the Western Regional Air Partnership. And then I've also, over the last 2 years, led the Denver ozone SIP modeling for the, as a serious ozone non-attainment area under the 2008 Ozone Nox. And I'm currently doing the modeling for the Denver as a severe non-attainment area under the 2008 NAX and a moderate non-attainment area under the 2015 Ozone NAX. And then I also led the photochemical modeling for the New Mexico Ozone Attainment Initiative. That's the subject of today's testimony.
And a copy of your resume has been provided as NMED Exhibit 107, correct?
That is correct.
Okay, and you've submitted direct and rebuttal testimony for this proceeding?
Yes, I have.
Okay, your full written direct testimony appears as NMED Exhibit 106, and your written rebuttal testimony appears as NMED Rebuttal Exhibit 11. Is that? Do you have any changes to your written testimony?
No.
And do you adopt your written testimony here today?
Yes.
Mr. Morris, can you summarize the results of the New Mexico photochemical modeling study?
Yes, I have a PowerPoint presentation to do that.
Okay, I think you should be able to share your screen and begin that presentation.
My share button seems to not be working.
It takes me a second. Hold on. Okay, now you should have it.
Still doesn't seem to be working.
It
Oh, there we
might
go.
take a second. And by the way, in the event, I'm not getting a low bandwidth signal for myself, but in the event you see me go dark, that's all I'm doing. I'm still sitting here. I but I may turn off my video if I continue to cut out. And I did just have, okay, please go ahead.
Is my screen sharing?
Yes, it is.
Okay.
Yes.
Okay, good. My direct testimony or rebuttal testimony. So this is a year-long study starting in April 2020 and for actually 13 months. And the steps in doing this study was starting with a modeling protocol. We're following EPA's ozone modeling guidance for SIP modeling, even though this wasn't a SIP. And the next step was we did a WRF meteorological modeling to get the meteorology for our modeling period. We had 2014 base case emissions that we adapted from the Western Regional Air Partnership. And then we did a CAMEX, which is a photochemical grid model, 2014 base case modeling and model performance evaluation. We developed new 2028 New Mexico oil and gas emissions, projecting those to 2028. And then we took the rest of the 2028 base case emissions based on the RAP 2028 OTB-A2. And those RAP 2014 and 2028 emissions are what was used in the Western States regional haze SIPs. So they've been extensively reviewed and evaluated and documented. We then did a CAMEX 2028 base case and a CAMEX 2028 New Mexico oil and gas control strategy case that had the rules we're discussing today. And then we assessed the ozone impacts of oil and gas controls. And finally, we did some ozone source apportionment modeling of the 2028 New Mexico oil and gas control strategy. During the course of this study, we had a website up on the RAP website where we documented the study as it occurred, starting with the modeling protocol in May 2020. We had monthly webinars with the New Mexico Environmental Division, and then we posted those PDFs up on the website. And then we had a couple base case modeling reports, and then in May 2021, we had an air quality technical support document. My direct testimony was based on that, and that was what was reviewed by Mr. McNally and Mr. Blewett. So to just back up a little bit, a photochemical grid model divides the domain that you're modeling into a series of grid squares or array of three-dimensional grid squares that are stacked boxes. We get the meteorological inputs from this weather research forecast meteorological model that gives you three-dimensional meteorological variables like wind speed, wind direction, temperature, pressure, water vapor, mixing ratio, precipitation, and all the meteorological, these kind of a weather forecasting model. There's concentrations around the outside of our domain that we call boundary conditions. So these are these come from a global chemistry model that RAP run for 2014. And then there are the emission inputs where you have gridded low-level emissions that go directly into the first layer of the model, and then elevated point sources that have plume rise and go into are injected in the upper layer of the models. And these emissions have to be processed to make them hourly gridded and speciated into the chemical species used in the chemical mechanism. And finally, the photochemical grid model itself, in this case CAMEX, simulates the transport, dispersion, the chemical transformation and deposition of the pollutants within this three-dimensional domain. And there's a simple schematic of the PGM there on the right. Okay, for the NMED Ozone Attainment Initiative, we ran with 3 nested grid domains of different resolution. The outer domain, the North American domain, had a 36-kilometer resolution. the inner domain. There's a 12-kilometer western U.S. domain, and those are the exact same domains used by RAP for the regional haze SIPs for the western states. But then we added a 4-kilometer grid resolution domain that covered New Mexico and surrounding areas, and we made sure we covered the San Juan Basin, oil and gas, and the Permian Basin. So we actually went into Texas quite a bit with the 4-kilometer domains. So these domains are two-way grid nesting, means that they pollutants flow in and out of them in the CAMX simulation. The boundary conditions I mentioned were based on RAP's 2014 simulation of the GeoChem global chemistry model. So those are the concentrations around the outer edges of the 36-kilometer domain. And then we actually did 2 WRF simulations and 4 WRF meteorological sensitivity tests, and we picked the meteorological inputs that gave us the best ozone performance within New Mexico. And then we had the 2014 emissions that were based on the RAP 2014 V2 emissions. That was in turn based on EPA's National Emission Inventory for 2014. And then we also used the RAP 2028 on the books A2 emissions for all 2028 emissions, except for the New Mexico oil and gas emissions, where we developed new base case 28 emissions. We did a model performance evaluation. I'm just going on one slide on that. There's two reports on that, but we use these standard model performance criteria, goals and criteria, and for normalized mean bias. The goal is within plus or minus 5%. And you can see on the right, shows the bias at each site. And when they're gray, they're within plus or minus 5%. If they're bright yellow, there's a slight overestimation. And you can see there is we're pretty much within the performance criteria at all the key monitors, so it's either bright yellow or gray, and within the performance goal at most monitors. We did evaluation in subregions looking at northern New Mexico, central New Mexico, and southern New Mexico, and found we did this with and without a cutoff. That means that no cutoff, we used all observed and predicted ozone pairs. With cutoff, we only looked at the high end of the observed distribution, so that's only the observed predicted pairs for ozone greater than 60 ppb. And we always achieve the ozone criteria, and we mostly achieve and almost always achieve the ozone goal with just the southern region without the cutoff being slightly above the plus or minus 5% goal. And the NMOGA expert modeling agreed that the ozone performance we saw was as good or better as most PGM applications that we've seen. And they agreed that it was a reliable PGM modeling platform for guiding emission control strategies in New Mexico. So moving into the part of the testimony, that this is the New Mexico base and control emissions. The difference plots on the left show the differences in NOx emissions on the top and VOC emissions on the bottom between the 2028 control strategy and the 2028 base case. On the left is the non-point oil and gas emissions. On the right is the point oil and gas emissions. The only difference in the 2028 base and 2028 control strategy was New Mexico oil and gas emissions. And you can see both VOC and NOx. You can clearly see the San Juan Basin and the Permian Basins showing there. The total emission reductions in that table there between the 2028 base and the 2028 oil and gas control strategy is about a 45% reduction in NOx emissions and a 50% reduction in oil and gas VOC emissions. And the control strategy only assumed controls in New Mexico. Mentioned the 2028 base case New Mexico oil and gas emissions. We projected those to 2028 using projection factors provided by BOM. They provided those around September 2020. The 2028 control case, we did not implement controls. We provided the base case to 2028 New Mexico oil and gas base case emissions to Eastern Research Group, ERG, and they implemented the controls and sent them back to us, and we processed them for input into the Photochemical grid model. And as I mentioned before, the remainder of the 2028 emissions were based on the RAP 2028 OTBA2 scenario, the same scenario used with Western States Regional Haze SIP. So we followed EPA guidance for SIP modeling, and the recommended procedures for making ozone design value projections is to use the model in a relative sense. I think Michael Baca talked about ozone design values defined as a 3-year average at the 4th highest maximum daily 8-hour ozone concentrations. So to project an observed ozone design value forward to the future year, you take the ratio of the modeling results for this case, the 2028 scenario to the 2014 scenario, and this ratio is called the relative response factors. And you use that to scale the observed ozone design value to get a future year ozone design value. And the idea being that these, by using the ratio of the future to current year modeling results, you limit some of the uncertainties in model bias. And so we're predicting in the current year is probably over predicting the future year, so that ratio's out. So you get your future year design value, the DVF, by just multiplying the current year design value by the relative response factor. So this is using the model in a relative sense. And the EPA default guidance is to use a current year design value based on 5 years or 3-year average of design values over 5 years centered on the base modeling year, which is 2014. So we end up using a base year design value based on an average design values from 2012 to 2016. So that's that DVC 2012-2016. And all these projections were made using EPA's software for model attainment tests with the default settings. So for the base 2028 base case, this is a table of projections of the future design value for 2028 base case based on the 2012 to 2016 current year design values. There are 2 sites that exceeded the 70 ppb 2015 ozone max, and that's 72.0 at Desert View and 71.3 at Santa Teresa, both in Donna Ana County. In the future year, using this EPA default guidance projection approach, all design values are below the 70 ppb ozone standard, with the highest one being in Desert View, that's 67 ppb, which is right at 95% of the max. And the reductions are anywhere from -2 ppb at Hobbs County and Lea, Hobbs monitor in Lea County, and -6.3 in La Union County, La Union's site. This is SMAT also has an unmonitored area test where it interpolates the base year design value from 2012 to 2016, and then you do projections across in every grid square. And this is a spatial map of 2028. I know that's the 2028 base case ozone design value, and then the differences between the 2028 oil and gas control case and the 2028 base case. The cold colors are reductions in ozone design values between 2028 base and the 2028 control case. The warm colors are increases in ozone design values between the, excuse me, 2020, sorry, this is 2028 base case and the 2014 base case. I'm getting ahead of myself. So this is the maximum design value is 68 ppb in the 2028 base, and you can see there are increases between 2014 and 2028 projected ozone design values in the San Juan Basin and the small spots in the Permian Basin. But everywhere else in New Mexico, there are reductions because there are large reductions in things like mold source, VOC and NOx between 2014 and 2028. But then we did the 2028 New Mexico oil and gas control strategy, and this shows the reductions in the 2028 base case ozone design values due to the implementation of the control strategy. And we see reductions by as much as 1.5 ppb at Navajo Lake and 1.2 ppb at Substation and 0.8 at Bloomfield. Those are all in the San Juan Basin. And the New Mexico oil and gas control strategy results in reductions of 0.7 ppb at Hobbs in Lehigh County and 0.3 ppb at Carlsbad in Eddy County. So these are reductions in 2028 ozone design value projections. And now these are the differences in 2028 ozone design values from the 2028 base case to the 2028 New Mexico oil and gas control case. And you can see that there are large reductions on the right. There's reductions in the 2028 design values. Again, the cold colors are reductions, and you see large reductions in the San Juan Basin up here with reductions as high as about 3 ppb. And then there's reductions as high as about 1 to 1.5 ppb down the Permian Basin. And I don't know, you can actually see these small pixel areas of red where actually ozone increased due to the oil and gas control strategy, and that's due to these NOx disbenefit effects. In other words, you control NOx, you can actually increase ozone locally, even though downwind it's going to reduce the ozone. So you can see that in these isolated spots in Permian Basin and in San Juan Basin. Oops. Wrong way. Okay. So in addition to looking at the modeling results in a relative sense, we also looked at the absolute modeling results on each day. And this is just examples of the 2028 base on the left, 2028 control case in the middle, and then there are differences on the right for 2 days. The top is June 4th, and that's the day when there's a peak ozone of 74 ppb right on the border of New Mexico and Colorado and the San Juan Basin. And then when you do the control case, that 74 ppb goes away, and there's an area of ozone exceedances in the base case. That's the yellow color. That's stretching into San Juan County and Rio Arriba County, and that goes away with the New Mexico oil and gas control strategy, so that all the ozone that was above the ozone standard in the base case is below the standard. That's in the middle top. And then on the right, you can see the large reductions in ozone by as much as 6 ppb, excuse me, as much as 2.8 ppb reduction. So that's a case in which the control strategy reduces ozone on a day that was modeled above the standard on June 4th in the base case to below the standard in the control strategy. The bottom is July 24th with the peak ozone 71.3. Again, it's right across the border in Colorado from New Mexico. And in the control case, the peak is 71 ppb, so that just barely exceeds the ozone max. And on the right, you can see the differences in the ozone concentrations on this day. And there's mostly reductions, especially in the Permian Basin, but there's an area with a 6 ppb increase in the middle of San Juan County. And that's actually the location where the ozone is at 71 ppb in the control case. So that's an indication of the NOx descent benefits. In other words, that's a more VOC limited ozone formation location, because you can see NOx descent benefits occurring there. Okay, so we looked at the sensitivity of the EPA projection approach to the base year ozone current year design value. These are the tables, the time series of ozone design values from 2010, year ending 2010 to 2019. The red are shaded for ozone design values that are greater than the 2008 75 ppb ozone standard. Yellow is above the 70 ppb 2015 ozone standard, and the green is above 95% of the 2015 ozone standard. And what we're seeing is that, at least in southern New Mexico, the ozone design values are going up over time. So using the current year's ozone design value from 2012 to 2016, that's the EPA default approach, does not account for these higher ozone design values in the more current year. So what we did is, and for example, the 2012-2014 design value had 3 sites over the 70 ppb standard, whereas the more recent 2017 to 2019 ozone design values has 6 sites over the 2015 ozone NAAQS and 3 sites actually above the 75 ppb 2008 NAAQS. So EPA modern guidance suggests making future year ozone design value projections using alternatives to the default approach. And one of the things they do mentioned explicitly in the guidance is to use an alternative to the base year design value. And we felt this was justified given this increase in ozone design values over time. So we did this projection to sensitivity analysis using a current year design value based on 2015 to 2019 5-year period for the current year design value. In this case, we had 4 sites that were above the ozone NAAQS. And when we did the projection for the base case, there is still 1 site above the ozone NAAQS at 71.2 ppb at Dona Ana, the Carlsbad site in Eddy County. And then for the 2028 New Mexico oil and gas control strategy, it actually reduced that 71.2 ppb down to 70.9 to below the ozone NAAQS. So this is a case where with this sensitivity analysis, the control strategy was sufficient to reduce the projected ozone design value in the base case that was above the 70 ppb ozone standard to below the standard. There are numerous more caveats in doing this sensitivity analysis and uncertainties than the EPA default approach, but this was felt this was warranted given the increase in ozone design values. We also did ozone source apportionment modeling using the 2028 New Mexico oil and gas control strategy emission scenario. We did 2 different source apportionment runs. One was a source apportionment run to look at the contributions of source sectors like natural emissions, fires, oil and gas point sources, oil and gas non-point sources, electrical generating units, other point sources, on-road mobile, non-road mobile, and other anthropogenic. And then that's we'll call the APTA ozone source apportionment source sector analysis. Then we did a second CAMX ozone source apportionment analysis called the OSAP, which is looking at VOC versus NOx sensitive ozone formation. So that provides a measure of whether ozone formation in New Mexico is more sensitive to VOC or NOx emissions. And to display that, I use this percent NOx sensitive ozone formation metrics. So it goes from 0 to 100%, and the percent VOC sensitive should just be 100 minus percent NOx sensitive. So the APCA ozone source apportionment was designed to answer the question, what are the ozone contributions of major source sectors in New Mexico to ozone concentrations under the New Mexico 2028 oil and gas control scenario, whereas to the OSAP VOC NOx sensitive source apportionment run is designed to answer the question, what is the relative importance, relative sensitivity of ozone formation to VOC versus NOx emissions? So this is the contributions of the various source sectors to the 2028 ozone design value under the oil and gas control scenario. And we separated oil and gas into point, non-point, and point. That's kind of a surrogate towards non-point is more production and upstream oil and gas, while point is more midstream. But the maximum contribution of oil and gas non-point is about 3 ppb, and for point 1.9 ppb, and that's comparable to other major source sectors like EGU point and on-road mobile, and greater than source sectors like non-road mobile, non-EGU point. So even under the 2028 oil and gas control scenario, there's still it's one of the major source sectors of still contributing to ozone in 2028 under control strategy. We also looked at the absolute ozone results from the source apportionment, and this is the left is the maximum ozone contribution for the non-point oil and gas, and on the right for the point oil and gas. And the maximum contributions is 7.6 ppb for the non-point oil and gas, and occurs in the Permian Basin at the intersection of the Eddy, Leon, Chavez counties. And the maximum contribution of oil and gas point sources is 5.4 ppb, and occurs just about the same spot at the intersection of 3 counties. You do see that the non-point has a substantial contribution in San Juan Basin, but point has a less so contribution. The NMOGA expert had these plots in their direct testimony, and we all agree that a vast majority of the ozone in New Mexico comes from outside of New Mexico or biogenic emissions in New Mexico. And so this is the contributions to the 2028 ozone design value from the APCA 2028 oil and gas controls source apportionment. And we're seeing that at least at these 3 sites, Navajo Lake in the San Juan Basin, Hobbs down in the Permian Basin, and Desert View in the Ana County in the Sunland Ozone Attainment area, that 91%, 96, and 96% of the ozone is coming from non-New Mexico anthropogenic emissions. So that's emissions outside of New Mexico or biogenic emissions within New Mexico. But if you look at the New Mexico anthropogenic emissions contribution and the contribution of oil and gas, 55% of the New Mexico anthropogenic emissions ozone contribution is from oil and gas. And at Navajo Lake, at the Hobbs monitor, 71% of the New Mexico anthropogenic emissions contribution is due to oil and gas sources. And Desert View, being further away from the oil and gas basins, is 20% of the New Mexico anthropogenic emissions contributions to the 2028 design value under the oil and gas control strategy is due to oil and gas emissions. And these contributions would be even greater in the base case before the oil and gas emission controls were implemented. This is an example of 2 days of the OSAT. So this is the VOC Nox Sensitive ozone. And I emphasize the scale here. Ozone formation in New Mexico is mostly Nox sensitive. The scale, you can see it's reddish, and from orange on up is 85% of the ozone formation is Nox sensitive. So it means that less than 15% is VOC sensitive over most of New Mexico. The one exception to this is that the ozone formation in the San Juan Basin is okay. This is one day, June 5th, but you can see that for all anthropogenic emissions, there's a little bit more VOC sensitive ozone in the San Juan County, and for New Mexico anthropogenic emissions, there's a little bit more. You got the blue, so that's getting down to almost equally VOC and Nox sensitive. And the scale was picked because ozone formation in vast majority of New Mexico is more Nox sensitive than VOC sensitive. It isn't an either or, it's usually both. But this is not surprising given the rural nature of most of New Mexico, that it would be mostly Nox sensitive. So the conclusions from the New Mexico Ozone Attainment Initiative's photochemical modeling study is that New Mexico oil and gas emissions are estimated to reduce ozone design values at the monitoring sites by as much as 1.5 ppb, and that's at Navajo Lake. And looking across the New Mexico, those reductions are as much as 3 ppb reduction in ozone 2020 ozone design values, and that's in the San Juan Basin. There are larger reductions in maximum daily 8-hour ozone. I gave the example of June 4th, a 4.6 ppb reduction, and for July 24th, a 2.8 ppb reduction. The episode maximum highest reduction is 7.5 ppb due to oil and gas non-point sources. And then the 2028 New Mexico ozone source apportionment modeling results. Most of the ozone in New Mexico is due to sources outside of New Mexico on biogenic emissions. across all the sites. It's 83% to 99% of the ozone. And then 2028 ozone 2020 design value for the oil and gas control strategy is due to sources outside of New Mexico. And although modest, New Mexico oil and gas emissions are a major portion of the New Mexico anthropogenic emissions contribution. As I mentioned, it's 55% at Navajo Lake, 71% at Hobbs, and 20% at Desert View. And then ozone formation in New Mexico is primarily NOx sensitive, with the exception of northwest New Mexico that exhibited more VOC sensitive ozone formation conditions. A few from my rebuttal report. One is Mr. Blewett states that the NMOA study did not document the 2014 and 2020 emissions. We did not document, outside of the 2020 oil and gas emissions that we developed, we did not document those in the air quality technical support document for the ozone attainment initiative because these were taken out of the RAP regional haze inventories, which are some of the most vetted and reviewed and documented inventories ever developed by each one of the Western states. And they're documented on numerous documents and websites and web pages on the RAP webpage. And that's where the documentation resides for those 2028 and 2014 emissions. That's one point. Mr. Blewett concluded that the modeling results do not support the need for additional oil and gas controls. I've presented technical information. Which sources you control is a policy decision. I just do the technical work. But some of the observations that, in facts in this matter, is that the observed 2015 to 2019 ozone design values exceed 95% of the 2015 ozone max at all sites in New Mexico except Santa Fe. And the AQCA requires the board to develop a plan to address ozone. My understanding is that these controls are part of that plan. There's a portion of Doña County that is Southern Park that's designated non-attainment with an attainment year of 2020 that it failed to achieve. Thus, the area may be designated as moderate ozone non-attainment with a 2023 attainment year. And then even with the implementation of the Part 50 oil and gas controls, the New Mexico oil and gas emissions are still a major fraction of the New Mexico total anthropogenic emissions contribution, which is the only sources that the board has regular authority to control. And I mentioned the 55% and 70% of the New Mexico anthropogenic emissions at Navajo Lake and Hobbs County. Mr. Blewett states that the New Mexico oil and gas emissions didn't include production declines or overstated, and it is included. These projections project a collection of wells of various ages. The emissions from a well are highest when they first go online, and they decline over time unless they're refract. So in 2014, and we have a collection of wells of various ages, including some in decline, and we project those emissions forward using a collection of wells. So they still have wells of different ages. So the 2028 oil and gas emissions also have a collection of wells of various ages and various stages of decline. Mr. Blewett also states that we should have separately evaluated the oil and gas VOC and NOx controls. Could have been done, but we didn't. But it wasn't. And in some cases, generally we look at control measures as a combined VOC and NOx emissions control, because that's just what's done in standard practice. And some control measures will obtain both VOC and NOx emission reductions, like reducing hours of operation. So it doesn't make sense to look at the separate contributions. But that being said, the modeling did suggest that ozone formation in New Mexico is mainly NOx sensitive, with the possible exception of the San Juan Basin, where there's a little bit more VOC sensitivity, but still it's mainly NOx sensitive. Also, there's some uncertainties in Mr. McNally's attempt to split the oil and gas ozone contributions between VOC and NOx emissions. And I don't doubt his basic conclusions that the oil and gas NOx controls produce the majority of the ozone benefits. But in my rebuttal report, I also listed some uncertainties in his approach that I don't need to go into details here, but it just increases uncertainties because you just can't, the way he did it, it just has more uncertainties. And finally, when ERG implemented the oil and gas controls into the 2020 base case emissions, they may not have counted NOx emission increases in some of the VOC control measures. And Mr. McNally suggested that not including the NOx emission increases in these control strategies like flaring would reduce any ozone benefit from the VOC controls and could worsen the ozone air quality. ERG provided an estimate of the NOx increases due to the oil and gas VOC controls, and they estimated it would increase NOx emissions by 67 tons per year. Now, though ozone formation is nonlinear, I kind of did a order of magnitude calculation and found that that 67 tons per year increase in NOx emissions would produce a maximum of about 0.002 ppb, so on order of thousandths of a part per billion. And both myself and Mr. McNally reported ozone results to the nearest tenth of ppb. Those increases in NOx emissions in the oil and gas control strategy would not have any material effect on the ozone results. In fact, if it was 10 times higher, 670 tons per year, it would still have no material effect on the ozone results. And with that, I conclude my testimony.
Thank you, Mr. Morris. Madam Hearing Officer, this concludes Mr. Morris's direct and rebuttal testimony, and he is available for questioning.
Thank you very much. I'm not sure whether the questions would require a look at the slides or not, so I think we'll leave it up for just a little bit.
Okay.
Let me start with Ms. Fox. Ms. Fox, do you have questions of Mr. Morris?
Madam Hearing Officer, I don't, but I am going to defer to my co-counsel, David Bach, who may or may not
All right.
have questions. Thank you.
Mr. Bach?
I do have just a brief question.
All right.
Thank you so much. So I wanted to ask briefly here, as I understood, the 2028 control strategy scenario was based on ERG's analysis of the rule. Is that correct?
That's correct. I have no opinion on how they implemented that.
Okay, so then perhaps you're not the person to ask about this. But if there were provisions of the rule that were not fully implemented by 2028, would I assume that would affect whether those inputs were correct?
That's correct. I just used the emission reductions that ERG implemented in 2028 New Mexico oil and gas emissions as they did. So they'll be on later this week. So
Okay. All right. Thank you.
All right.
No further questions.
Thank you. Ms. Paranos?
Thank you, Madam Hearing Officer. I have no questions for this witness.
All right. Thank you. Professor Pasiniak or Mr. James?
Thank you, Madam Hearing Officer. No questions at this time.
All right. Thank you. Ms. DeVore or Mr. Vimont?
No questions. Thank you.
Thank you. Mr. Nykiel or Mr. Timmons?
No questions, Madam Hearing Officer. Thank you.
Thank you. Mr. DeSalen?
No questions. Thank you.
All right. Mr. Heiser?
Madam Hearing Officer, we will have a couple of questions for Mr. Morris, please.
All righty.
So, Mr. Morris, it's good to see you this morning, and thank you for that explanation of the very complicated photochemical grid modeling that you have done. If you could turn to your direct testimony in NMED direct exhibit number 106, and for any of our board members who might want to follow along, it'd be exhibit 106. On page 5 of your testimony, you state that, and I quote, "The biogenic VOC may not be the largest source sector, but is usually still a large component of VOC emissions," unquote. Does New Mexico include areas where biogenic emissions are the largest component?
Yes, I would guess that over a majority of New Mexico, the biogenic emissions, it's pretty rural, so the biogenic emissions, VOC emissions would be the largest source sector. It's only in the oil and gas fields and the, Albuquerque, Las Cruces, the urban areas where it may not be the largest VOC
Thank
source
you.
sector.
And you talked a couple of places here about NOx disbenefit. Is there any reason to believe that the areal extent of NOx disbenefit in New Mexico is very great?
No, generally they're fairly small. They're very isolated to where the NOx source is located. When you reduce NOx and ozone goes up.
And in the one example on one of your slides, and unfortunately don't remember which one, in the San Juan area, does it look like that's partially related to the power plant up in the Four Corners area?
Yes, you get NOx disbenefits where there's high NOx concentrations. In the Four Corners power plant was assumed, some of the units, I forget, unit 4 and 5, soon to be still operating in 2028. So that produces high NOx concentrations.
Okay. Now, if we advance to page 11 of your testimony, where you're talking about the impacts to proposed Part 50 at the top 2 sites in the San Juan Basin, I think you said it was negative 1.5 part per billion and negative 1.2 part per billion. But were the results at the other monitors in the San Juan Basin about 0.8 part per billion or less? And it's page 15.
Yeah. Going to mine.
Take your time.
I think it was, yeah.
Oh, it's page 11. Yeah, sorry, page 11. I misspoke. I've misled you. I'm sorry.
In the San Juan Basin, it's yes, 0.8 ppb to minus 1.5 ppb.
And similarly, you state that the results of the proposed Part 50 rule in the Permian Basin were negative 0.7 part per billion at Hobbs, negative 0.3 at Carlsbad, but aren't the results negative 0.2 part per billion or less elsewhere within the Permian?
Those are the only 2 monitors in the Permian Basin, were Hobbs and Carlsbad.
So the other monitors there are the balance of southern New Mexico?
Yes.
In your report?
Mainly Delhanna County.
In page 12 of your testimony, am I correct in reading that the proposed Part 50 rule perhaps contributes 6.4 part per billion to local ozone concentrations in San Juan County, causing a NAX exceedance on one day that might not otherwise have occurred?
Yes, that was in my presentation I just made.
Does EPA distinguish between a state control strategy caused exceedance and any other type of exceedance, assuming that the control strategy exceedance is ineligible for classification as an exceptional event in determining whether an area goes into non-attainment?
Non-attainment is based on monitoring data, not modeling data, and the monitoring data does not distinguish, well, does not tell you where the ozone came from. It's just a measured value.
It's just a measured value regardless of the source.
Yes.
On pages 14 and 15, you testify about the model emissions inventory that you used. Acknowledging that you did not develop this inventory, at least in part. I know that Ramble's been integrally involved with the Western Regional Air Partnership in developing the overall inventory. But based upon the evaluation of what was provided to Ramble, was it consistent in quality and depth with emissions inventories that are usually relied upon government agencies and the Western Regional Air Partnership and emissions forecasting?
I believe so. I didn't catch some of that question because I had some background noise here.
I'm sorry, I can repeat it for you if you'd like.
Thank you.
So on pages 14 through 15, you testify about the model emission inventory that you used and acknowledging that Ramble did not develop this inventory. Based upon your evaluation of what was provided to Ramble, is it consistent in quality and depth to the emissions inventories usually relied upon by government agencies and the Western Regional Air Partnership in emissions forecasting?
Yes.
In figure 4 on page 19 of Exhibit 106, do you know from your just general study of this area what the biogenic VOC emissions would be on the same tons per day basis, approximately?
I can find that information, but I don't have it off the top of my head. It would be probably much higher than these.
Okay.
Because that's statewide.
And then on table 3 on page 20 of 3, the same question, what would the biogenic VOC emissions be on a tons per year basis?
I don't have that information off the top of my head. I believe Mr. McNally had that in his report, and it's probably in the air quality technical support document of the Ozone Attainment Initiative.
Would it likely be higher than the numbers that you're seeing there?
Yeah, because New Mexico is mostly rural.
The question for you then, more generally on the chemical relationship and the formation of ozone, does NOx preferentially select anthropogenic VOC over biogenic VOC, or will it simply react with whatever VOC is available?
Well, it reacts with the total VOC, and it doesn't distinguish between anthropogenic and biogenic, but some compounds are more reactive than other VOC compounds.
Right, there's a sort of a scale of reactivity.
Yes.
So if we exclude the biogenic VOC in these charts, does that have the apparent effect of flattering the impact of the rule when much of the inventory is simply being unaffected and unchanged?
Well, the only emissions you can control are the anthropogenic emissions. You can't control the biogenic emissions. So, you know, the rules going after anthropogenic New Mexico emissions, which is the only thing you can control.
So if I circumscribe a circle of 100 marbles and say that I can only choose between these 4 marbles and I choose 2 of those marbles, that's basically what you're saying here.
In terms of
Objection.
it's
I believe that Mr. Morris said that it didn't distinguish between anthropogenic and biogenic.
Madam Hearing Officer, Mr. Morris said that he limited the discussion to what was within his perception of the department's jurisdiction. And I was saying, if you simply do that, doesn't that cause the number to go up?
All right, Mr. Morris, do you understand the distinction being made by both your counsel and Mr. Heiser?
Yes, I'm not sure if the analogy is a good one, but you know, I will say that there is more biogenic VOC in New Mexico than there's anthropogenic VOC emissions.
Thank you, Mr. Morris. And then page 32 of your testimony, and my apologies to the board for now sinking into jargon. You discussed the 2018, and you variously referred to it, I think, as the 2018 PCM or PGM guidance. Which is the proper acronym so I use it correctly with you throughout?
Well, the 2018 EPA guidance is for ozone, PM2.5, and regional haze, SIPs. So you call it the ozone modeling guidance.
Okay. And then is there also photochemical grid model guidance?
Well, that is the same thing.
Oh, that is the same one. Okay. So we'll just call that the 2018 EPA guidance for now. Does that guidance use a relative response factor or an RRF?
Yes, that was what I presented in my testimony.
And is part of the purpose of that RRF to adjust for sort of unknown and unknowable emissions and model formulations or emissions or the meteorology to provide sort of a correction factor?
Yes, it uses the relative change in the model results, so that if you have for example, you have an overestimation, it's probably in the base in the future year, and by taking the ratio, you kind of factor that out.
In page 41 of your testimony in table 5, do you agree that looking across the monitors, the impact of the proposed Part 50 rule appears generally greater in the San Juan Basin than in the Permian Basin?
That's correct.
In section 10 of your report, and this is section Roman numeral 10, which is called Sensitivity of the 2028 Ozone DVF Projections to Current Year Ozone DVC, isn't it true that you're no longer using the model in a relative sense here, but now you've started to use it in an absolute sense?
No, this is section, you're talking about section X?
Section X, yes.
Page 46. No, this is the 2028 ozone design value projection sensitivity test to the current year design value. So instead of using the current year design value, observed current year design value from 2012, 2016, I use the current year design value from 2015 to 2019.
So in your testimony where you state that you're now using certain values in an absolute sense, what does that mean?
That means we're using the 2028 CAMX modeling results in an absolute sense, as they come out of the model, not in a relative sense, to project to those design values.
Okay, so it didn't go back and look at the monitor differences in the past in this case. You just used the straight model results.
Yes.
Okay. Are the high ozone, I'm going to back up and ask you sort of a more general question here. Are the high ozone days that are projected in the work that you've done, are they the same at each monitor or do they vary across the monitors? In other words, is it the same 10 days at each one, or are they often a mix of days across the monitors?
It can vary across the monitors. If there's two monitors in close proximity, they may have many of the same days, but these relative response factors mentioned are based on 10 days, and they're likely different days for like monitors up in the San Juan versus monitors in the Permian Basin.
Okay. And do you continue to agree that the CAMX OSAT simulation estimates that ozone formation due to New Mexico anthropogenic emissions is primarily NOx sensitive across most of New Mexico, with the exception of the few instances you've noted in the San Juan and even fewer in the Permian Basin?
It's mostly NOx sensitive across most of New Mexico, and the possible exceptions in San Juan County, and there is some VOC limited, small amounts of VOC sensitive ozone elsewhere too.
And then you never ran the model just looking at NOx only or VOC only controls, right? You did different ways of it, but you didn't just run the model with the NOx or the VOCs. That was your testimony. Did I understand that correctly?
Yes.
Why not?
Because we're looking at the control strategy that was a collection of control measures that control both VOC and NOx at the same time.
Okay. You didn't think that there would be value in trying to further tease out the relative sensitivities of NOx and VOC?
Not in the time frame that we had to do the study.
Okay, thank you. With that, I'd like to switch over to your rebuttal testimony. And Mr. Morris and board members, that would be NMED rebuttal exhibit number 11. Let me know when you've got that in front of you. Perfect, okay. In page 3 of your rebuttal, you state that it's standard practice to regulate both VOC and NOx in critiquing Mr. McNally's testimony, sort of implying that Mr. McNally was advocating a no VOC control strategy. Does industry support of a phase out of the high bleed pneumatic devices within 2 years, a phase out by 2030 of most other pneumatic devices, new controls on existing storage tanks exceeding 6 tons per year, new tanks at 2 tons per year, leak detection repair requirements on well sites and gathering and boosting stations, pig launchers and receivers and hydrocarbon liquid transfers sound like a no VOC's control strategy to you?
Objection. Mr. Morris wasn't involved in any of the testimony regarding, or the analysis of the actual rule requirements.
I'm asking you directly about his testimony, Ms. Katz.
I don't have an opinion on how the rule was implemented in the 2028 New Mexico oil and gas emissions, because that was done by ERG.
Okay, so why didn't you?
In his testimony where he's identifying all those provisions specifically?
He states that it's not appropriate to look at parsing away the VOCs, implying that we are suggesting that no VOC controls are appropriate. And I'm just asking if he considered what was actually in the record before he made that statement.
Which page?
You're characterizing his testimony.
Page 3.
Hold on, Mr. Heiser. You did refer to his rebuttal testimony, which is ED Rebuttal Exhibit 11. But which page are you looking at?
Madam Hearing Officer.
Sorry?
Page 3.
Page 3. Thank you.
I don't think I ever characterized Mr. McNally as promoting a no VOC control strategy.
All right, fair enough. In section 2.3 of your rebuttal testimony on page 6, you state that Mr. McNally's analysis using the ABCA data, which Ramble provided, it has some uncertainties and possibly is unreliable. Wasn't Ramble's choice of modeling approach, which processed the data using the ABCA protocols without preserving the previous data, what precludes Mr. McNally from being able to make that analysis without the compromised data?
I listed several points that led to uncertainties in the way Mr. McNally processed the APCA results to get the separate ozone contributions due to the controlled oil and gas, VOC, and NOx emissions. One of them is that it was a oil and gas control strategy, so it wasn't the base case pre-control. Another is the use of the APCA ozone tool that doesn't preserve the ozone and VOC NOx sensitivity. It has a preferential treatment of that. You should use the OSAT tool for that.
Yeah, but I mean, wasn't it Ramble that ran the APCA analysis overall and provided the data then to Mr. McNally?
Yes.
Okay. So that was really, he used the data that's available to him. Is that correct?
That's correct.
Okay.
He could have run his own analysis.
By rerunning the entire model?
Yes.
Isn't it true, Mr. Norris, that despite your quibbles with Mr. McNally's statement, that you still concede on page 8 of your rebuttal testimony, lines 15 to 17, that there's no question that the modeling indicates that ozone formation in New Mexico is more NOx sensitive than VOC sensitive, and it's likely due to that a majority of the ozone benefits of Part 50 shown in the modeling are due to the NOx emissions reductions?
I think I just testified to that effect.
You don't, and you have no reason now to disagree with that prior testimony that you've made.
Yeah, probably most of the ozone reductions are due to the NOx emission reductions, although VOC emission reductions, those ozone reductions are not zero.
Okay. And so does that mean that for most days that controls on NOx on a ton for ton basis are going to be more effective than controls on VOC on a ton for ton basis?
That would be what I expect. We didn't analyze that explicitly.
In page 9 of your rebuttal, with regard to the possible NOx emissions increase resulting from the controls that were contemplated under the Part 50 rule, isn't it true that you really offered no opinion on the accuracy of ERG's estimated emissions reductions on this topic?
Yes, I do not have an opinion on ERG's emission reductions that they implemented in New Mexico on gas emissions.
And by including that ERG rebuttal in your summary on the last slide today, are you now adopting the ERG approach despite your earlier offering of no opinion on that analysis, or do you continue to offer no opinion on that analysis?
That analysis was assuming that the ERG's NOx emission increases due to the controls is 67 tons per year, that have no material effect on our results, or even if it was 670 tons per year, it would have no material effects on the ozone results presented by myself or Mr. McNally.
Finally, on page 19 of your rebuttal, you state that the observed 2017 to 2019 ozone design values exceed 95% of the 2015 ozone NACs at all monitoring sites in New Mexico except Santa Fe. Is that true of Rio Arriba monitoring site if you'd considered the 2018 to 2020 design value?
I did not look at that, but I believe Michael Baca testified to that effect yesterday.
Thank you very much, Mr. Morris. As always, it's informative and to speak with you about modeling issues. Thank you so much for the work that you've done on this. It's really an impressive amount of analysis. That's all my questions, Madam Hearing Officer, for Mr. Morris.
Thank you so much. Mr. Rose, do you have questions of Mr. Morris?
I do, Madam Hearing Officer, hopefully just one, since Mr. Bach had questions that related to what I was going to ask. Mr. Morris, in terms of the analysis that you did, or the run that you did with respect to the ozone initiative, it was, as I understood your testimony, you were given a set of reductions based on this rule, and that's the only option that you looked at in terms of the model. Is that correct?
Well, we ran 3 scenarios: the 2014 base case, the 2028 base case, and this 2028 New Mexico oil and gas emissions control case. And that's the only control case we ran.
Okay, that any other options would have been requested, and I take it questions about why this particular ozone control case as opposed to others was modeled. We'd have to ask ERG about that.
Yeah, I think you'd have to ask New Mexico Environmental Division as well as ERG.
Okay, that's all the questions I have, Madam Hearing Officer.
All right, thank you, Mr. Rose. Mr. Jano?
No questions, Madam Hearing Officer.
Thank you. Mr. Boutier?
No questions, thank you.
Thank you. Ms. Gutierrez?
No questions, thank you.
Thank you. Mr. Newman?
This is Chris Colclaser for the Commercial Water Group. We have no questions.
All right, thank you, Mr. Colclaser. And Ms. Witherspoon?
No questions.
All right, thank you very much. I'm going to turn to the board members now to see if they have questions. If there's anyone else with questions who is not a panelist, please reach out in the chat. Madam Chair, do you have questions of Mr. Morris?
Thank you, Madam Hearing Officer. At this point, I don't have any questions, but I do want to just thank the witness for his extensive work that he's presented, and also the slides have been very helpful. Thank you.
All right, thank you. Madam Vice Chair, Trujillo Davis, do you have questions of Mr. Morris?
Yes, thank you, Madam Hearing Officer. I do have a couple of questions, and I just want to start off by thanking Mr. Morris also for his presentation. It helps digest a lot of this information, so thank you for that. So I had some just kind of basic questions about this. Mr. Morris, have you run this type of modeling in the past for any other rules that were going to be promulgated?
In other locations?
Yes, sir.
Yes, I've done ozone SIP modeling for somewhere between 10 and 20 cities, and that includes the Denver ozone SIPs dating back to 2003. And for example, they have a Reg 7 oil and gas rule that we've modeled, and I've done it for many other locations throughout the U.S.
And it used similar constraints when modeling those ones and the ones for the current rules we're looking at right now.
Yes, generally we look for ozone SIP. We do kind of an iterative process of controls, see what the result is, and see whether we need more controls. And this was kind of a mini SIP in that the time frame didn't look at all other controls. For example, we only looked at the oil and gas control strategy. We didn't look at mobile source or industrial source controls outside of the 2028 base case.
And after those rules were promulgated, have you ever gone back and looked at that modeling and how it matches up to the real world conditions after those rules have been in effect for a while?
Yeah, we've done that a couple times. The problem is that you model a future year, you're assuming that, in this case, we assume the 2014 meteorology occurred in 2028. Usually meteorology affects ozone greatly, so that when like a lot of areas had like a 2007, a 2020 or 2017 attainment date or something, and that year comes around, the meteorology is actually different. And like for the Denver, we had a 2020 ozone attainment date. And when 2020 came around, not only was the meteorology different, the emissions were very different due to the COVID. So it's the future year assumes the same meteorology as the current year. So it's hard to do that, but there are some retrospective studies that have looked at that.
And I don't know if you can answer this because it's probably a pretty big question, but how, when you look at those retrospective studies, how accurate are you? I mean, statistically, like, are you within some level of accuracy, or is it outside that that value?
Well, in the past, it was, there's sometimes it was higher, sometimes lower. More recently, we're seeing that the observed ozone is higher than what we projected, and part of that reason is due to climate change. The summers are hotter. They're more conducive to ozone formation than in the past. So they produce more ozone just because the meteorology is different.
Would you be able to maybe look at the effectiveness of those previous rules based on retrospective modeling?
You could. You can't predict future meteorology. I mean, this has been affects climate change on ozone has it's been known that you get hotter summers, you get more ozone. It's called the climate penalty, which means that an ozone control plan developed under current climate conditions may be insufficient in the future under climate change. So factoring that in, you have to factor that into the evaluation.
So the modeling that you use in this one and the meteorology conditions that were used, could you change those conditions so that they had like worst case scenario and we could see, I mean, I'm not asking you to do any of this. I'm just trying to get a sense of, can that modeling go in that direction where you change the meteorology conditions and they're a little more headed the direction that you're saying that we're going with increasing temperatures in the summer?
You can't do it. It's very complicated. You have to downscale climate model to your, in this case, the WRF model. It's just a very complicated and intensive thing to do correctly.
And where do you get your parameters for that meteorological data?
Well, we use the weather research forecast model, and it's like a numerical weather prediction model. What is a numerical weather prediction model? And it ingests observed analysis fields, because we're doing retrospective modeling. We're modeling an historical situation. So it does data assimilation of observations so that you match the current, the observed meteorology for that year. In this case, it was 2014.
Okay. Thank you for indulging my questions. I appreciate it. And I appreciate all the work that you did on this.
Thank you.
Thank you. Member Cates, do you have questions of Mr. Morris?
No questions, thank you.
Thank you. Member Bitzer.
A couple quick questions. Thank you, by the way, for a very thorough presentation. Credentials are impressive. One of your slides had the little red dots where you're actually having, even in the, I guess, due to mitigation equipment, there's little spots where the number actually goes up. Would it be safe to assume that those little red dots are away from population centers? Those are, or could those be co-located little red dots with urban areas?
Well, those little areas of ozone creases due to the New Mexico oil and gas controls are probably located at NOx point source, oil and gas NOx point sources. And so, I don't know the layout of the oil and gas point sources and the population, but it's probably away from a population center. But there could be a residence nearby. I just don't know.
And then it seems to me that we're an enormous portion of our issue is outside of our control, and that we're working within that narrow band that we have some influence over. Would it be possible if we keep getting hotter and we stay warm longer, that we could turn all the oil and gas off in New Mexico, do no mining, no extraction whatsoever, and still end up in non-attainment?
It's possible that you will get ozone exceedances and potentially non-attainment due to sources outside New Mexico. There are a few provisions in the Clean Air Act to address that. There's the Good Neighbor policy, and also this Section 179B, international emissions, but for demonstration that you can do.
Are you done, Member Bitzer? Okay. Member Garcia.
Yes, Madam Hearing Officer, I do have a question for Mr. Morris. Thank you, sir, for your presentation. My question is regarding the factors and parameters you took into account into this modeling. I know you took into account increased temperatures with climate change, et cetera, and the production of ozone due to that. Also, projections of oil and gas activity, for the next 7-8 years, et cetera. Did you also take into account out-of-state sources and what projections might be for Texas, for instance, or influences of activity in Mexico? I know that Doñana is a non-attainment area, and some believe that much of that could be due to activities in Mexico. So that has a big influence on non-attainment, or could have a big influence on non-attainment. So I'm wondering how you factored in the out-of-state sources.
Well, first, for the climate change, we assumed that the 2028 meteorology was the same as 2014. So we did not factor in increased temperatures. We did, for the New Mexico oil and gas, we did get a 2028 activity projections in New Mexico from Bureau of Land Management. And then for sources outside of New Mexico, we use the RAP 2028 on the books emission scenario. So that's just, that would be control strategies, measures that are on the books as of when they made that emission inventory, which was probably a year and a half ago. So it included, future year controls on Texas sources, like on-road mobile source emissions. Mexico, I can't remember what the assumptions were there, but those emissions are much more uncertain than those in the US.
Thank you. That's all my questions, Madam Hearing Officer. Thank you.
All right, thank you. I believe I heard you say that was all of your questions. Member Honker, do you have questions for Mr. Morris?
Yes, thank you. And Mr. Morris, I'd like to join my fellow board members in thanking you for the excellent presentation. Just one question. I was a bit unclear on the point source versus non-point source differentiation. Could you elaborate a little bit on that in terms of what you consider a point source versus non-point?
Okay, well, the non-point sources are mainly the sources at the well. So this would be the upstream emissions at the wells sites, and then the point sources will be, sources that have plume rise, like a large compressor or a gas plant. So those would be a surrogate for the midstream sources. And so we separated those out to try to get a separation of the mainly upstream sources from the midstream sources.
Okay, that's helpful. Thanks. No other questions.
All right, thank you, Member Honker. Mr. Knight or Ms. Katz, will there be any redirect? I don't see anyone reaching out through the chat to ask a question. Will there be redirect? Mr. Knight?
Sorry,
No.
Madam Hearing Officer, no, we have no redirect for this witness.
Okay, thank you very much. Is there any reason not to excuse Mr. Morris?
None that I'm aware of.
All right, thank you very much, Mr. Morris, for your testimony.
And Madam Hearing Officer, can you unshare me? Because I'm not sure how to do that in WebEx.
I will do that right now.
Okay, thank you.
We're going to take a break. I think this is a good time for the break. And let's take 15 minutes and come back at, that would be 10:55. Yes, 10:55.